Now, a common question that comes up is, okay, I get it, wildcard masks. You take the normal mask, you invert it, and boom, that becomes the wildcard mask. That's true. However, what if the network is not on nice, clean octet boundaries? Maybe you've got a 27-bit network or a 21-bit network. How do you figure out the wildcard mask for that? Well, we're going to do it the same way that we did for OSPF. I'm going to walk you through that right now. So let's imagine that we want on this router, router 1, on its gig 00 interface to have an access control list that says we want to permit all the address space here inside of Arizona. So we'd first have to decide, remember the 3 basic rules of access control list is plan it, and then create it, and then apply it to an interface. Those are the 3 basic steps. So as we take a look at the plan, the address space for Arizona is 10.16.0.0/21. And then over in Nevada, they're using 10.16.8.0/21. And down here in Florida, it's 10.16.16.0/21. So if we wanted Arizona to go ahead and permit or deny or match on that block of addresses, which is not a clean octet boundary, how do we do that? So to identify that in an access control list, we'd use that network, 10.16.0.0, and then we would put in the inverse mask. So a great question to start with is, what is the normal mask that represents the 21-bit network? Well, the first 8 bits are on in the mask. In the normal mask, that's 255, that's 8. And then 8 more, that's 255. And then we have some additional quantities. So for writing out our table, 128, 64, 32, 16, 8, 4, 2, and 1. And we'll imagine that this is our 16-bit boundary right here. To get to 21, we'd need 17, 18, 19, 20, 21. And then the rest would be zeros for our mask. So there's our block size of 8 if we need to create additional networks using the /21. So for this third octet, for the normal mask, it would be 128 plus 64 plus 32 plus 16 plus 8, which is 248. And then the last octet would be a 0. So all we need to do for the wildcard mask is flip that. So in our access control list, we'd specify network 10.16.0.0. That's the network. And then for the wildcard bits, it'd be 0 here. We flip all those. 0 here, flip all those. For the last octet, flip that, be a 255. And the question is, what about this third octet here? And we could take it in binary and flip it there. So I'll go ahead and use a different color here. I'll use red for the wildcard mask. If we flip each of these bits in binary, it'd be 0, 0, 0, 0, 0, and 1, 1, 1. And then we just add up the bits that are on in the wildcard mask, which is 4 plus 2 more plus 1 more, which is 7. Another way of doing that is we could take the value of 255 minus the value of the mask in that octet, and that also equals the value for the wildcard mask in that position. And these techniques are the same ones that we used when we were doing network statements with OSPF and wildcard masks. So if our plan, for whatever reason, is to deny all traffic sourced from 10.16.0.0/21 from coming inbound on this interface, we would specify 10.16.0.0/21. We do that with the appropriate wildcard mask, deny. And then we'd also want to add a permit for everything else. So for everything else, we'd want to go ahead and permit. And for this exercise, I've reset the lab. Let's use access list number 3 with a deny statement for the 10.16.0.0 network with this wildcard mask. We'll create the second permit statement for everything else. So here from our client PC, let's do a persistent ping with a ping space -t space 192.168.1.100 and press enter. Because there's no access list currently on gig 00, after we apply the access list that denies everything in 10.16.00/21, it should include this PC, which is at 10.16.0.10. So let's go to our management PC, which is DCNUG. We'll open up PuTTY in the upper left-hand corner, and we'll open up a connection over to R1. So here at R1, we'll do a show access list. Always a good idea, just to make sure we know what we're dealing with before we start adding any new access control lists. So we'll go into configuration mode, access list. We'll use the number 3, we'll deny, and we're looking for 10.16.0.0. And then for the wildcard mask, we're going to use 0.0, meaning we care about all 16 of the first bits, and we only care about the first 5 bits of the third octet. And we're going to put a 7, which means we don't care about the last 3 bits in that third octet, followed by a 255, which means we don't care about matching on any of the bits from the last octet. And let's also add the keyword of log here. And I thought I put a period there, but I didn't. I'm going to hit the up arrow key, and I'm going to put my period there before the 7. Fantastic. Press enter. And then we'll create our second entry, which is going to permit everything else. Access list, 3, permit, any, and press enter. So once we apply this, any traffic sourced from 10.16.00/21 and any of the IP addresses or ranges beneath that are going to be denied. Then we'll go into interface gig 00, and we'll do an IP access group, and the number 3, and in, and press enter. And it shouldn't be long before we get a console message. There we go. Because I've got the continual ping that's going on from PC1. Because we got the continual ping that's going on from our PC, and there is other network traffic that is being sourced from the 10.16.00/21 address space. So if we do a show access list, here's our access control list. We've had a whole bunch of matches, and it gets worse. Check this out. So this is a packet from our PC in VLAN 10. This is a packet from the Core 2 multilayer switch. This is a packet from the Core 1 multilayer switch. And because we have a deny for everything from that 10.16 address space /21, we are killing our routing protocols too. So based on our plan, by saying we want to deny all traffic coming from 10.16.00/21, we not only denied that traffic, but we also broke the network, because we broke routing, and now reachability is lost, and we've caused even more problems for ourselves. And that's why it's an important thing to do 3 things with access control list for filtering. Number 1, plan on explicitly what we want to permit or deny. 2, create the list. And then 3rd, implement them and verify that they're doing what we intend them to do. So I'm going to reset this lab in preparation for our very next video, and I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.